Simple linear regression. A simple linear regression model is a statistical tool used to understand the relationship between two variables, an independent variable and a dependent variable. It assumes a linear relationship between the two variables and aims to find the best fitting line that represents the relationship. The independent variable, also known as the predictor variable, is the variable that is believed to have an impact on the dependent variable, also known as the response variable. A simple linear regression model seeks to determine how changes in the independent variable affect the dependent variable. In a simple linear regression model, the relationship between the two variables is represented by the equation y equal beta naught plus beta 1x plus epsilon. The regression coefficients beta naught and beta 1 need to be estimated. Y is called the dependent variable, S is independent variable. Beta naught is called the population Y-intercept and beta 1 is called the population slope coefficient. Epsilon is the random error. The y equal beta naught plus beta 1x is the linear component. Compare with this. What is this y equals 3 plus mx? That is the equation of the straight line. It is very similar to the y equal beta naught plus beta 1x. This part is called the random error. Now let me consider this. Suppose this is the best line for this data set. That means this is the regression line. There are 2 points on the line and other 2 points are out of the line. There are vertical distances between these 2 points and the line. So these vertical distances are called errors. But the previous point that are on the line have no any errors because they are on the line. We can write this formula as y equal beta naught plus beta 1x plus epsilon. We need to estimate beta naught and beta 1. Then we can write this as y hat equal a plus bx. A is the estimator of beta naught, B is the estimator of beta 1. Let me explain this using this example. Assume this is the regression line. For this case, y hat equal negative 2461 plus 297x. Compare with this. What is the A? A is negative 2461 and B is 297. A is the y-intercept and B is the slope. You see here y-intercept is negative, therefore it should be below the x-axis. Now consider this example. I explained this example in a previous video. There are 4 points and draw the regression line for this case. Here house price is the dependent variable. It depends on the square feet or size of the house. Therefore, x is the independent variable which is square feet here. Now consider this point. X is 1500, y is 300. So 300 is coming from the table. Therefore, 300 is called observed response. That is the y value. How many observed response we have in this example? There are 4. What are those? 240, 300, 350 and 330. Now consider this one. That is y1. That is called the predictor response. How do we find the y1? Y1 can be estimated using the equation y hat equal a plus bx. I will explain this later in this video. Now consider this point. X is 2000, y is 350. This point is on the line. Therefore, observed response and predictor response Both are the same. That means y equal y hat. Now let me explain how to estimate beta naught and beta 1. We use this method which is called the least squares regression line. The least squares regression line of y on x is the line that makes the sum of the squares of the vertical distances of the data points from the line as small as possible. What is the meaning of that? We know errors. Errors are the vertical distances. Then we find these errors of each point. According to this, squares of the vertical distances. We find the error and get the second power of these errors. Then we add them together. We need to minimize that expression as small as possible. Let me explain this using this example. First, let me consider this line. How do we find the errors? First one, 1, 2. 2 is the observed value. 1 is the predicted value. How do we find the vertical distance? 2 minus 1. Then get the second power. Go to the next one. Y value is 4. Y hat is 2. 4 minus get the second power. Next one. 1.5 minus 3 to power 2. Next one. 3.2 minus 4 to power 2. Then add them together. It is 6.89. Then go to the second line. I consider the horizontal line. We can find the vertical distances as known as errors. How do we find it? We know we can use the same thing what we did before. That one is 3.99. Which one is the best line from these two? The second one. Why? The smaller the sum of square differences, the better the fit of the line to the data. So this is the least squares method. The least square regression line is the line y hat equal a plus bx. How do we find the a value and b value? B is the slope and it is r time sy over sx. And a is the intercept, y-intercept. It is y bar minus b x bar. R correlation coefficient, sx is standard deviation of x, sy is standard deviation of y, and x bar and y bar are mean of x and y respectively. How do we find the r? Using this formula. I explained this in the previous video. And how do we find the standard deviation? This is the standard deviation of x values and this is the standard deviation of y value. Then we know how to estimate the beta naught and beta 1. Estimated y value or we call predicted y value. And a is the estimate of the regression intercept. It is the estimator of the beta naught. And b estimate of the regression slope. Yes, it is estimate of the beta 1. And this is the least square regression line. It is again y hat equal a plus bx.